we were at a network layer. Network layer is a third layer of a OSI model. Even it is a third layer of the TCP/IP model also. So the network layer communicates with the transport layer at the top and the data link layer at below. The main functionality or the main role of a network layer is to translate the logical address into physical address and vice versa. It even determines the route from the source to destination, and in a case of the traffic, it manages the traffic problem and congestion due to the traffic, and it accordingly it finds the routes for the packet. Fine. So the main important role for the network layer is to move the packets from sending host to the receiving host. So routing is the main functionality of the network layer. So let us see the functionalities of the network layer. So the functionalities are routing, logical addressing, internetworking, and fragmentation. In routing, the network layer is responsible for finding the route for a given packet. For example, if the packet comes from the source S1 and it has reached to the router R1. Now this router R1 is supposed to find out the route for the packet, further route for the packet, and that is the task of the network layer at the router. Fine. So the router is responsible for forwarding that given packet to the next router on the path of S2, that is my destination. Correct. The next important functionality of network layer is logical addressing. Now what does happen in logical addressing? Basically, we use a physical address at a data link layer and we use a logical address at a network layer. Correct. This logical address is used for distinguishing between source and destination system. The network layer adds the header, and in that header it includes the logical address of source, that is a sender and a receiver. So the important task of the network layer is to convert the physical address into the logical address, and then that logical address of the source and destination is added in the header of the network layer. In a networking, the main role of the network layer is to provide the connection between different types of networks. So as I already said to you, that the routers are also having the network layer. So what does the networking, in the networking we do? In the networking, we get a visibility, in the internetworking we get a visibility that all the devices or all the networks are connected to each other via network layer. So that is my internetworking. Correct. And the next important task was a fragmentation. So fragmentation में क्या होता है? Over here, it is the responsibility of the network layer is to divide packets into smaller individual data units, right? And this individual data units travel through the different networks. So that's my fragmentation. So these four are the important functionalities of network layer, and with this four functionality it provides the service to upper layer, which is a transport layer, and the lower layer, which is a data link layer. Now before going into details of the network layer, we will first see the switching techniques. Okay. Now, in the large network, there will be multiple paths that linking sender and receiver. Correct. As we have already seen, you must have studied the Digistar's algorithm and then shortest path algorithm in second year. So over there, we have seen that from source to destination, we have multiple paths. The same, that concept of multiple paths is applicable over here also. So information can be switched as it travels through various communication channel. So there are three typical switching techniques, right? What do you mean by switching techniques? So it decides about the path to be followed, right? So how the path to be followed is to be decided, or how the traveling will happen, that is my switching technique. So there are three types of switching techniques. The first is a circuit switching, then we have a message switching and a packet switching. Fine. So in a circuit switching, it's over there, the directly sender and receiver are connected with unbroken path. So there is a dedicated line between sender and receiver, and that line is never broken. So that is my circuit switching. So as I yesterday also told you, the telephone switching equipment is an example of circuit switching. It establishes a path that connects the caller's telephone to receiver's telephone by making a physical connection, right? So that is my circuit switching. So in the type of the switching technique, in this particular type of a switching technique, once our connection is established, a dedicated path exists between both ends until your connection is terminated. So always we have the dedicated path in a circuit switching, and it is established at the start of a communication, and it will be broken only at the end of the communication or after the communication. So over here, the routing decisions are made when circuit is first established. And once the circuit is established, the routing decision cannot be changed. It is whatever routing decision is decided while establishing the service will remain consistent or will remain same till your communication is over. So that is my circuit switching. So all of you, what you have to remember is the example for circuit switching is our telephone switching equipment. So we have the copper cables, dedicated copper cables for the telephone lines, and once the path is established in a telephone line, it is never interrupted by any other process or by any other telephone call. So that is my that is my circuit switching example. Fine. So what are the things in a circuit switching? So circuit switching operate almost the same way as a telephone system. A complete end-to-end path must exist before communication can take place. The computer initiating the data transfer must ask for a connection to the destination in a circuit switching. So before establishment of a connection, the destination must send the acknowledgement to source node to indicate that it is ready. So what does happen in a circuit switching is, first the connection is established. While establishing the connection, the destination has to acknowledgement about its readiness for receiving the packet. And once the acknowledgement is received by a source from a destination, then only source will start for send and receive of the data. And at the end of a communication, again the connection will be broken by a sender. So this is how the circuit switching happens. So the concluding line for the circuit switching, that it is having the dedicated path, and before the communication the path has to be set. Once the path is set, it is never changed till your communication is over. Fine. So that is my circuit switching. So the advantages of circuit switching is we have the dedicated channel for the communication once it is established. Right. Now there are few disadvantages for this circuit switching. So there can be a long wait to establish a connection. Right? Do you remember the olden days telephone calls? Over there, we need to wait for our number to get connected to the exchange, right? So that is the example of long wait to the establishment of the connection, right? So during which the data is not transmitted over before the connection, before the establishment of a connection, data cannot be transmitted, and this particular establishment of a connection itself can be a longer time, correct? Then more expensive than any other switching technique because a dedicated path is required for each connection. And the last disadvantage is it is an inefficient use of a communication channel. Right? It may happen that both the systems are connected, and at this moment they are not transferring the data. Right? As though they are not transferring the data, they may need to transfer data say after 10 minutes. But they are holding the connection, right? And unless and until they are holding the connection cannot be used by the other two stations, right? So that's the reason we say that it is the inefficient use of a communication channel, because that communication channel is not free, and unless and until it is not free, it cannot be used by anybody else. So that is my circuit switching. Understood, all of you? So let's move to the message switching. So in a message switching, there is no need to establish a dedicated path between two stations. When a station sends a message, the destination address is appended to the message, right? And the message is then transmitted to the network in its entirely from node to node manner. So the message is just transferred from node to node manner, and the destination address is appended in the message. So the message itself finds its path. So each node receives this message, stores it in the disk, stores it on its disk, and then transmits the message to the next node. This type of a network is called as a store and forward network. So what we do in the message switching? So in a message switching, whichever node receives the message, it stores that message on the disk and then transmits the message to the next node. So that's the reason we say it is at a store and forward network. So look at the screen, it is a message switching technique. So you can see that the path of a message 2, which is a blue color. So you can see that with this path, the message 2 is getting forwarded to the destination. And similarly, the message 1, even it has to reach to the same destination, still it is following the different path. So in the message switching node, it's like we have the general purpose computers. So these devices should have the sufficient storage capacity for the incoming message to get stored, right? And in this case, the main point is there is a time delay which is introduced in forwarding a data because first thing it is doing the store and forward, and the next part is it has to find the next node in the transmission path. So these two things takes a time, and that's the reason there is a time delay which is introduced in a message switching technique. Fine. So there are few advantages of message switching techniques. The first part is the channel efficiency can be greater compared to circuit switching because more devices are sharing the channel. Then traffic congestion can be reduced because the message may temporarily stored in a route. Then the message priorities can be established due to the store and forward technique. So whichever message is having higher priority will be forwarded, and if the message is having low priority, they can be stored as it is. Then these messages the broadcasting is achieved very easily with this message switching technique because we can apply the broadcasting in the message itself, right? So these are few advantages of message switching technique. There, of course, there has to be some disadvantage also, as there are disadvantages for the system. That's the reason we are searching for the new techniques, right? So it is not compatible with interactive applications. And whenever we come for the stored and forward technique, it is expensive because it needs to hold a space, which is a huge space in the disk, and that's the reason in the sense of the space complexity, this particular method is not at all efficient. It is very, very expensive when we go on thinking about the stored and forward method of this message switching technique. Fine. Now, till now, what we have seen circuit switching, we have seen message switching. Now let's look at the packet switching, which is actually a most efficient technique where the channel utilization is a maximum. So what happens in the packet switching? Now packet switching itself is a solution that tries to combine the advantages of message switching and circuit switching both, and it tries to minimize the disadvantages of this both techniques. So you can see that there is a diagram, and what does this diagram shows? It shows the packet switching, that is a datagram, and virtual circuit for the packet switching. So what does happen in a packet switching? You can see there are numbers, and these numbers these packets are having numbers, and every packet is following some different path. Say 1 is going with this path, then 2 may follow the other path, then 3 is going with this path. So in this manner, every packet is following a different path or a shortest path or a congestion free path at that moment, and then it tries to reach to the destination. Fine. So in both packet switching methods, these are two methods of packet switching. First is a datagram packet switching and the virtual circuit packet switching, right? So in this, both the methods, the message is broken into small parts, which is called as a packets. So here we don't transfer the message as it is. We break it into small parts, and then which are the numbered. These particular small parts are numbered parts, and they are called as a package. So this particular packet, every packet is tagged with the source and destination address. Correct. Now these packets are having their own maximum length, right? So they can be stored in the main memory instead of the disk. Right? If you can understand, if this a complete message, a used message, it may happen that it may not be possible to store that complete message on a disk or on a RAM, right? Because RAM is a limited memory, correct? But suppose RAM or a main memory. But suppose instead of that, if we break the message into smaller packets, तो smaller packet का कैसे अपना definite length है. Now this particular length is easy. This particular length of the message or a packet is easy to store on the main memory, the disk memory. And as we don't have to store it on the disk, it may not take a long time to retrieve the data from the disk because the main memory data is easily and efficiently available for the CPU, right? And that's the reason this particular is having the less delay and the less cost also, this particular method of packet switching. As even because of it, that transmission speed between the nodes is optimized, right? So with the current technology, packets are generally accepted onto the network on the first come first serve basis. If the network becomes overloaded, packets are delayed or discarded. That we generally say as the packets are dropped. Correct. That's the reason we say that the congestion and the flow has to be managed on the network. If it is not managed very well, then it may be overloaded, and then the packets may be dropped. Correct. So the size of packets can be 180 bits for the Dacquit virtual circuits. These are few examples. Even it is 1024 or 2048 bits for the 1 PSS switch, even 53 bytes for the 18 switch, such as the Lucent technology packet switches. So these are the examples. The different technology, different proposed technologies are following different packet size of the message, which is to be transmitted across the network, right? So in a packet switching, the analog signal from your phone is converted into digital data stream. Then this digital bits is divided into relatively tiny clusters of bits, which are called as a packets. Fine. And with each packet at its beginning, the digital address, a long number to which it is being sent, right? So that is appended at the start. Correct. They travel across the nation's digital backbone system to their destination, like a telephone system or anything else, right? So in a packet switching, what we do, the data is converted to digital system. Then the destination address is appended, and then your packet is traveled through your communication system, right? It is not necessary that these packets travel together, and even they don't travel sequentially also. Whatever way is available, or the way where there is less congestion, less traffic, that way will be followed by a packet. Fine. So just the aim for the packet is to reach to the destination address, which is appended at the start. Fine. So every packet have just a single aim to reach to destination, though they follow the different paths, and that's the reason at the receiver end also it will not be necessary that the packets are received in a same sequence, and so we mark packets with the sequence number, and those sequence number are easily retrieved back at the receiver end. Correct. Now this packet switching datagram we have and virtual circuit types we have. Correct. So there are few advantages of packet switching. So packet switching is a cost effective. Then it offers the improved delay characteristics. Packet can be rerouted if there is any problem. And the main part is it uses the network efficiently. Of course, they are having disadvantage also.